This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what is glycolysis? Answer: glycolysis is the metabolic pathway that converts glucose into pyruvate and generates ATP and NADH. Question: what is the net equation for glycolysis in the cytoplasm? Answer: the net equation for glycolysis in the cytoplasm is glucose plus 2 pi plus 2 andarin pesetas plus 2 Namibia dollars plus equals 2 pyruvate plus 2 ATP plus 2 NADH plus 2H plus 2 H2O. Question: is the equation for glycolysis balanced chemically? Answer: the equation is not balanced chemically, and the exact balance equation depends on the ionization state of reactants and products. Question: what are the key enzymes in glycolysis? Answer: the key enzymes involved in glycolysis include hexokinase, Phosphofructokinase, aldolase, Triosephosphate isomerase, Glyceraldehyde 3-phosphate dehydrogenase, phosphoglycerate kinase, and pyruvate kinase. Question: what is the role of hexokinase in glycolysis? Answer: hexokinase is an enzyme that catalyzes the conversion of glucose to glucose 6-phosphate, the first step of glycolysis. Question: how does phosphofructokinase regulate glycolysis? Answer: phosphofructokinase is a key regulatory enzyme in glycolysis, controlling the rate of the pathway by catalyzing the conversion of fructose 6-phosphate to fructose 1,6-bisphosphate. It is allosterically inhibited by high levels of ATP and activated by high levels of AMP. Question: how does aldolase catalyze the second step of glycolysis? Answer: aldolase catalyzes the conversion of fructose 1,6-bisphosphate to 2 molecules of glyceraldehyde 3-phosphate, the second step of glycolysis. Question: what is the role of triosephosphate isomerase in glycolysis? Answer: triosephosphate isomerase is an enzyme that catalyzes the conversion of glyceraldehyde 3-phosphate to dihydroxyacetone phosphate, the third step of glycolysis. Question: what is the function of glyceraldehyde 3-phosphate dehydrogenase in glycolysis? Answer: glyceraldehyde 3-phosphate dehydrogenase is an enzyme that catalyzes the oxidation of glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate, the fourth step of glycolysis, that also generates NADH as a byproduct. Question: how does phosphoglycerate kinase catalyze the fifth step of glycolysis? Answer: phosphoglycerate kinase catalyzes the conversion of 1,3-bisphosphoglycerate to 3-phosphoglycerate, the fifth step of glycolysis, by transferring a phosphate group from 1,3-bisphosphoglycerate to ADP, generating ATP. Question: how does pyruvate kinase catalyze the final step of glycolysis? Answer: pyruvate kinase catalyzes the conversion of phosphoenol pyruvate to pyruvate, the final step of glycolysis, by transferring a phosphate group from phosphoenol pyruvate to ADP, generating ATP. Question: how is the rate of glycolysis regulated? Answer: the rate of glycolysis is regulated by both allosteric regulation and hormonal regulation. Allosteric regulation occurs through enzymes such as phosphofructokinase and pyruvate kinase, which are activated or inhibited by certain molecules. Hormonal regulation occurs through hormones such as insulin and glucagon, which stimulate or inhibit the pathway. Question: what are the end products of glycolysis? Answer: the end products of glycolysis are pyruvate, ATP, and NADH. Pyruvate can be further metabolized in the citric acid cycle to generate more ATP, while NADH is used in the electron transport chain to generate ATP via oxidative phosphorylation. Question: what are the energy investments required for glycolysis? Answer: the energy investments required for glycolysis include the conversion of glucose to glucose 6-phosphate and the conversion of 2 andarin pesetas to 2 ATP. These energy investments are needed to drive the pathway forward and to generate a net gain of 2 ATP per glucose molecule. Question: what is the role of NAD plus and NADH in glycolysis? Answer: NAD plus and NADH play a crucial role in glycolysis as cofactors for enzymes such as glyceraldehyde 3-phosphate dehydrogenase and lactate dehydrogenase. NAD plus acts as an electron acceptor, becoming NADH after accepting electrons from the substrate. NADH, in turn, can transfer electrons to the electron transport chain for ATP generation. Question: how does the process of glycolysis relate to other metabolic pathways? Answer: glycolysis is a central metabolic pathway that is closely related to other pathways such as the citric acid cycle and the electron transport chain. Pyruvate, the end product of glycolysis, is converted to acetyl-CoA and then enters the citric acid cycle, where it is oxidized to generate more ATP. NADH, and ATP generated during glycolysis are also used in the electron transport chain to generate more ATP via oxidative phosphorylation.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the First Aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.